a strategic river crossing in eastern Ukraine where single bridge provided only crossing point for heavy vehicles across deep river in 40-kilometer sector. Bridge was 85 meters length, spanning river measuring 40 meters width and 8 meters depth. Structure was reinforced concrete construction built during Soviet era, substantial engineering work representing significant infrastructure investment. Bridge enabled civilian and military traffic connecting separated territories, critical transportation link in regional network. River presented major obstacle to military operations. Water depth 8 meters prevented wading by infantry or fording by vehicles. Current approximately 2 meters per second prevented easy swimming or improvised crossing. Water temperature -1 Celsius created severe hypothermia risk. Immersion survival time measured in minutes. Riverbanks were steep, requiring constructed approaches for vehicle access. Without bridge, crossing required specialized engineering equipment, pontoon bridges or amphibious vehicles that Russian forces in sector lacked in sufficient quantity. Ukrainian military command assessed bridge as vulnerable strategic asset. Bridge enabled Russian mechanized forces to cross river advancing toward Ukrainian defensive positions beyond. Defending bridge directly against Russian assault would be difficult. Ukrainian forces lacked sufficient strength to hold against determined attack. Alternative approach was demolition, destroying bridge to prevent Russian use accepting loss of Ukrainian infrastructure. Decision represented difficult trade-off. Preserving bridge maintained future Ukrainian mobility. Destroying bridge denied immediate Russian operations. Poll: should defending force destroy own infrastructure to deny enemy use? A. Always deny enemy mobility. B. Preserve for future friendly use. C. Depends on tactical situation. Comment strategy assessment. 6 seconds after Ukrainian engineers detonated bridge demolition charges, catastrophic collapse would occur. Central support pier destroyed by explosives causing complete structural failure. 85-meter bridge span falling into river, carrying 34 Russian vehicles positioned on roadway. Vehicles falling 12 meters from bridge deck to water surface. Impact force crushing vehicle structures and killing occupants. Vehicles submerging in 8-meter water depth, sealed armored vehicles becoming death traps for crews unable to escape. 178 Russian soldiers killed. Majority drowned in submerged vehicles, others killed by impact trauma. Some died from hypothermia after escaping into freezing water. Total Russian losses: $89 million, including destroyed vehicles, killed personnel, and strategic mobility loss from crossing denial. Ukrainian demolition cost $180,000 in explosives and engineering effort, but accepting permanent loss of bridge infrastructure valued at approximately $18 million. Trade-off was accepted. Sacrificing own bridge was worthwhile to eliminate Russian mechanized column and deny enemy crossing capability. This happened 9 days ago when Ukrainian forces destroyed bridge under Russian column attempting crossing. Bridge remains as collapsed rubble in river-blocking crossing site. Russian forces abandoned sector seeking alternate routes, requiring extended detours. Tactical implications of Ukrainian willingness to destroy own infrastructure continue affecting Russian operational planning. Recognizing Ukrainian forces will sacrifice assets to deny enemy use. This is what occurred during 3 weeks when Ukrainian engineers prepared demolition. During hours when Russian column crossed bridge. During 6 seconds when bridge collapsed, killing 178 Russian soldiers. Bridge demolition represents military engineering operation, requiring technical expertise and precise execution. Demolition must be planned to ensure complete destruction. Partial damage, leaving usable structure, fails objective. Explosives must be positioned at critical structural points, support piers, load-bearing sections, connection joints, where detonation causes catastrophic failure. Timing must be controlled, enabling detonation at optimal moment, maximizing enemy casualties and denying enemy use. Demolition teams must balance preparation against discovery. Enemy detecting demolition, preparations may disable charges or avoid crossing. Ukrainian combat engineer team received demolition mission 3 weeks before execution. Team consisted of 12 engineers, specialists in explosive demolition, structural assessment, and tactical operations. Mission planning required analyzing structure, identifying demolition points, calculating explosive quantities, achieving complete destruction, preparing detonation systems enabling remote activation, concealing preparations, preventing Russian detection. Structural analysis identified central support pier as critical demolition point. Pier was reinforced concrete column supporting center span of bridge. Destroying pier would cause center section to collapse, dropping vehicles on roadway into river. Pier was accessible from beneath bridge. Engineers could work from riverbank, placing explosives on pier base without being visible from bridge deck or approaches. Demolition required 40 kilograms C4 plastic explosive, creating shaped charges directing blast force into pier structure. Ukrainian engineer team infiltrated to bridge position during darkness 23 days before demolition execution. Movement was covert. Small team traveling light with explosives and equipment, avoiding Russian patrols, approaching bridge from concealed route along river. Team reached bridge at 0200 hours, beginning preparation work, under cover of darkness and bridge structure. Explosive charges were emplaced on central pier over 4-hour period. Engineers worked beneath bridge from rubber boats on river, accessing pier base below waterline where charges would be most effective. 40 kilograms C4 was divided into 8 shaped charges positioned around pier perimeter. Each charge focused blast inward, maximizing structural damage. Detonation cord linked charges ensuring simultaneous detonation. Blasting caps were installed connected to remote firing system using radio-controlled detonator. Charges were camouflaged against casual observation. Explosive packages were wrapped in waterproof covering colored to match concrete, preventing visual detection from distance. Detonation cord was run along pier structure hidden in existing cracks and joints. Radio detonator was concealed in pier cavity, accessible only from water, preventing Russian detection during bridge inspections from deck level. Ukrainian engineers extracted before dawn, completing 4-hour operation without Russian detection. Demolition was prepared, explosives in place, detonation system functional, bridge ready for destruction when commanded. Following 3 weeks involved waiting for optimal opportunity. Large Russian vehicle column attempting crossing, presenting maximum value target. Debate starter: is destroying own infrastructure to deny enemy use militarily sound or wasteful? Infrastructure costs money to rebuild, but denying enemy mobility has value. Type sound tactic or wasteful destruction. Ukrainian reconnaissance maintained continuous observation of bridge monitoring Russian activity. Drone surveillance documented Russian vehicle movements approaching bridge, infantry patrols securing bridge perimeter, engineer teams inspecting bridge structure for damage or sabotage. Russian inspections from bridge deck level failed to detect Ukrainian charges placed underwater on pier base. Inspection was inadequate, missing concealed demolition. Russian forces planned major crossing operation using bridge. Mechanized column of 52 vehicles was assembled for movement across river toward Ukrainian positions. Column composition: 11 T-72B3 main battle tanks providing armored firepower, 14 BMP-2 infantry fighting vehicles carrying mechanized infantry, 27 trucks and support vehicles transporting ammunition and supplies. Total personnel: 412 soldiers including vehicle crews and infantry passengers. Column represented substantial combat power, battalion strength force capable of offensive operations. Russian crossing commenced at 1300 hours with lead elements entering bridge. Crossing procedure was methodical. Vehicles maintained spacing, preventing overload of bridge structure. Speed was slow, minimizing dynamic stress on roadway. Security elements observed for threats. Russian engineers had inspected bridge that morning, finding no obvious damage or hazards. Assessment was bridge was safe for crossing. Ukrainian observers monitored crossing, counting vehicles entering bridge. Observation post was positioned 800 meters from bridge with clear view of approach and crossing. Observer used rangefinder and video camera documenting Russian movement. Count was transmitted to Ukrainian engineer commander controlling demolition detonator. Vehicle 1 crossing, Vehicle 5 crossing, Vehicle 12 crossing. Communication enabled precise timing of demolition, maximizing vehicles on bridge when detonation occurred. Optimal detonation moment occurred when maximum vehicles occupied bridge center, span directly above demolition charges. Ukrainian engineer commander calculated ideal count: 34 vehicles on bridge positioned such that bridge collapse would drop all into river. At 13:18, observer confirmed 34 vehicles on bridge, center span full, detonation recommended. Ukrainian engineer commander transmitted detonation signal at 13:18:47. Radio signal activated remote detonator connected to blasting caps installed in explosive charges. 8 shaped charges detonated simultaneously, creating focused blast waves directed into central pier structure. Combined explosive force 40 kilograms C4 generated approximately 60 megajoules energy, equivalent to 40 kilograms TNT. Blast shattered reinforced concrete pier, destroying structural integrity instantaneously. Central pier collapse caused immediate bridge failure. 85-meter span lost support at center point, creating cantilever configuration impossible for structure to sustain. Concrete roadway cracked at quarter points on each side of destroyed pier. Center section 40 meters length separated from approach sections and fell toward river. Full time approximately 1.2 seconds from height 12 meters. 34 Russian vehicles on collapsing bridge section experienced catastrophic event. Vehicles were on roadway when structure failed, dropping suddenly with deck collapse. 11 tanks weighing 45 tons each, 14 BMPs weighing 14 tons each, 9 trucks varying weights, all falling simultaneously. Impact with water occurred at approximately 15 meters per second velocity, creating enormous forces crushing vehicle structures and killing occupants. Quiz: how long can soldiers survive in -1 Celsius water before fatal hypothermia? A. 30 minutes, B. 10 minutes, C. 3 minutes. Answer at minute 15. First impacts were catastrophic. Tanks struck water surface with massive force. Driver compartments crushed by impact. Turrets separated from hulls. Crews killed instantly by trauma. BMPs impacted nose first. Front sections crumpled. Crews and passengers thrown against interior surfaces, suffering fatal injuries. Trucks hit broadside. Cabs crushed. Cargo compartments destroyed. Drivers and passengers killed. Vehicles immediately began sinking in 8-meter depth. Tanks descended rapidly. 45 tons mass pulled vehicles to river bottom within 30 seconds. BMPs sank quickly, 14 tons each submerging completely within 1 minute. Trucks varied, some sank immediately, others floated briefly before filling with water and descending. Most vehicles reached bottom within 2 minutes of impact. Russian soldiers inside vehicles faced impossible survival situation. Vehicle compartments flooded rapidly, water entering through hatches, vision ports, damaged sections. Escape required opening hatches against water pressure, physically impossible for most crew members. Some soldiers attempted escape through rear doors or turret hatches, finding exits jammed by impact damage or blocked by water pressure. Majority remained trapped inside sinking vehicles, dying from drowning as compartments flooded or from injuries sustained during impact. Estimated 178 Russian soldiers were in vehicles falling from bridge. 15 soldiers escaped sinking vehicles, emerging from hatches as vehicles sank, swimming to surface, reaching riverbank. These survivors suffered severe hypothermia from water exposure, requiring immediate medical treatment, preventing death from exposure. 163 soldiers died in vehicles or water. Majority drowned trapped in flooded compartments. Some died from impact injuries. Approximately 12 died from hypothermia after escaping vehicles but succumbing before rescue. Russian survivors on bridge approach sections and those waiting to cross witnessed catastrophe. Soldiers watched center span collapse, vehicles fall, bridge structure destroyed in seconds. Shock and horror paralyzed initial response. Soldiers couldn't process what had occurred. Officers attempted organizing rescue, but options were limited. No boats available for water rescue, no equipment for vehicle recovery, medical support inadequate for mass casualties. Ukrainian artillery engaged Russian forces on riverbanks beginning at 13:20, 90 seconds after bridge collapse. M777 155mm howitzers fired high-explosive rounds targeting concentrations of Russian vehicles unable to cross destroyed bridge. Artillery fire killed additional Russian soldiers and destroyed vehicles. Exact casualties difficult to determine amid chaos of bridge collapse, but estimated additional 30 Russian soldiers killed by artillery. Russian forces attempted rescue operations for survivors in water, but faced severe challenges. Water was freezing. Rescued soldiers required immediate warming, preventing fatal hypothermia. Current swept some survivors downstream, requiring search along riverbank, finding soldiers before they drowned or died from exposure. Underwater recovery of trapped soldiers was impossible. No diving equipment available. Current and depth prevented free diving. Soldiers in submerged vehicles were certainly dead by time recovery could be attempted. Russian command assessed bridge crossing operation as total disaster. 34 vehicles lost, 11 tanks valued at $26.4 million, 14 BMPs at $9.8 million, 9 trucks at $1.08 million. 178 soldiers dead, bridge crossing denied. No alternate crossing capability existed in sector, meaning Russian advance was blocked indefinitely. Operational failure forced complete revision of offensive plans requiring extended detours or abandonment of operations in sector. Here's the financial breakdown of 6 seconds, where Ukrainian demolition destroyed Russian column. Economic analysis revealed concentrated vehicle losses, creating massive financial impact. 11 T-72B3 main battle tanks at $2.4 million each totaled $26.4 million. 14 BMP-2 infantry fighting vehicles at $700,000 each totaled $9.8 million. 9 trucks at average $120,000 totaled $1.08 million. Combined vehicle losses, $37.28 million. Personnel casualties, 178 soldiers killed, represented $9.79 million training investment. Average $55,000 per soldier. Death benefits averaged $50,000, total $8.9 million. Additional 30 soldiers killed by follow-on artillery represented $1.65 million training investment and $1.5 million death benefits. Strategic mobility loss from bridge destruction created operational costs. Russian forces required extended detours, adding 100 kilometers to movement routes, consuming fuel, time, creating logistic strain. Alternate crossing development using pontoon bridges required specialized equipment and weeks of effort. Estimated strategic cost from crossing denial, $20 million in operational delays and logistics complications. Combined Russian losses, $89 million, including vehicles, personnel, and strategic impacts. Ukrainian demolition costs. 40 kilograms C4 explosive at approximately $3,000 per kilogram, $120,000. Radio detonator and blasting caps, $8,000. Engineer team operation costs, $52,000. Total demolition cost, $180,000. However, comprehensive Ukrainian cost must include bridge infrastructure loss. Bridge was valued at approximately $18 million. Permanent destruction meant future Ukrainian forces also couldn't use crossing. Decision to demolish represented accepting $18 million infrastructure loss to achieve $89 million enemy loss. Cost-benefit calculation favored demolition despite permanent infrastructure sacrifice. Strategic implications validated demolition doctrine when defending against superior enemy forces. Destroying own infrastructure denied enemy mobility, creating operational barriers, forcing extended movements. Ukrainian forces demonstrated willingness to sacrifice own assets when doing so, inflicted greater enemy losses. Total war mentality, accepting all costs necessary for victory. Tactical lessons emphasized importance of reconnaissance, detecting demolition preparations. Russian bridge inspections failed discovering Ukrainian charges. Inspection methodology was inadequate, missing underwater placements. Proper inspection required divers examining all structural elements. Procedure Russian engineers didn't execute. Lesson was clear: crossing infrastructure in combat zone requires thorough inspection detecting concealed demolitions. This is Ukrainian combat engineering, where $180,000 in explosives destroys $89 million in Russian forces. Where Ukrainian engineers sacrifice own bridge because denying enemy crossing worth permanent infrastructure loss. 34 Russian vehicles fell 12 meters into freezing river. 178 soldiers died. Bridge collapsed in 6 seconds. Ukrainian forces proved they will destroy everything to deny Russian advance. How should Russian forces inspect bridges for demolition before crossing? Comment your engineering procedures.